Great, so 7.5 talks about angles and things inside a quadrilateral. So here I have a quadrilateral. Remember, a quadrilateral is anything with 4 sides. Okay, I've pre-measured out my midpoints. So I have a midpoint here, which means these are both the same length. I have a midpoint here, which means both sides are the same length. I have a midpoint here, which means these guys are all the same length. And last but not least, I have a midpoint here, which means those are all the same length. Okay, so in my quadrilateral I drew here, all 4 sides were different, so my midpoints splits this one in half, splits this one in half, splits this one in half, and splits this one in half. So what I want to see is what happens when I connect those guys. I don't know. So let's do it. Let's see what it looks like. So, line, 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 and line. So I've made another quadrilateral inside. Okay. Is it a special kind of quadrilateral? Let's figure that out. Let's check, where'd my protractor go? Let's check angles. So here I have 120 degrees. And here I have 120 degrees. Nice. Okay. Here I have 62 degrees, 60 degrees. And here I have another 60 degrees. That's really cool. So, what does that mean? Well, it means that these guys become a parallelogram. Which means those sides are the same, and these guys are the same. Neat, eh? So when I take my midpoints of a quadrilateral, we will create a parallelogram. That's an important conclusion to make. So conclusion, oops. In any quadrilateral, connecting the midpoints will always produce a parallelogram. Okay. So our next thing we want to look at is, well, what happens if I connect those midpoints with these midpoints? So they're the midpoints in the quadrilateral, but they're also the vertices of my parallelogram. What does that create? Well, let's look. So let's connect these. And let's connect these. Oops. I wiggled that a little bit. And let's check. Let's see. Total length is 15.5. And oh look, it's exactly in the middle. No way. Let's check here. Total length is, what's that, 26? And the dot is right at 13. No way. This is 13. This is 13. That's so cool. So my diagonals of a parallelogram, here's second conclusion, bisect each other. So the diagonals bisect each other. That's really neat. So we're going to use that to solve some problems. So let's see. Problem number 1. Says, here's a random quadrilateral. Given x, y, z are midpoints, and given that one angle is 72 degrees, can I figure out my other angles? Well, definitely, since they're a parallelogram, definitely we can figure that out. So because they're midpoints, I can therefore conclude that those lines are parallel and these lines are parallel. Okay, so since x, y, z, and w are midpoints. Therefore, XW is parallel to YZ, and XY is parallel to WZ. So that's important. And since they're parallel, therefore, let's see. I can use my parallel line theorem C pattern. So if I use that here, then that tells me that angle WXY plus 72 degrees has to equal to 180. So that means angle WXY equals 180 minus 72 gives me 108 degrees. I can do the C pattern down here now. So angle XWZ plus angle WXY, I'll have to add up to 180 degrees. So that means angle XWZ plus 108 is 180. So the angle I'm looking for, XWZ, is 72 degrees. And then last but not least, so there's my 108, there's 72. What's the last one? Well, again, I can see it, like I can do the C pattern. So these are all parallel line theorem C patterns. Angle WZY plus 72 equals 180 degrees, right? Still parallel line theorem C. Angle WZY is 108. So these opposite angles in a parallelogram are always equal to each other. 108, 108, 72, 72. Just like when I drew it. 60, 60, 120, 120. Fun, eh? Oops. Okay. How about example 2? So here I'm giving you a random quadrilateral. And I just randomly drew it, whatever. And I'm going to tell you that AB is parallel to DC. And I'm going to tell you that AD is parallel to BC. So I'm telling you that this is a parallelogram. I'm telling you that AE is 5 centimeters. So this section here is 5. And I'm telling you that DE is 7. So this section here is 7. Can I find the rest of my lengths of my diagonals? Sure can. So because this is a parallelogram, I know that my diagonals will bisect each other. So since ABCD is a parallelogram, therefore E bisects AC and E bisects BD. So that means AE equals EC. So that means EC is going to be 5. And it means that DE equals EB. So that one's 7. Well, since this length and this length is 5, so AC is equal to AE plus EC. So what's that? 5 plus 5? That's 10 centimeters. And last but not least, DE plus EB is going to give me my total DB. So that's DE plus EB. 7 plus 7 gives me 14. Whoa. And there you have it. There's 2 lovely examples of how to use today's cool knowledge.